So we'll be solving some questions on linear inequations in one variable. So this is the first question. So it is given that if the replacement set is the set of natural numbers starting from 1 up to infinity, 1, 2, 3, 4, 5, 6 up to infinity, natural numbers capital N, which is represented by capital N, find the solution set of the following two inequations. Okay. First inequation in one variable, it is represented as 3x plus 4 is lesser than 16, and the second inequation is 8 minus x is lesser than or equal to 4x minus 2. Okay, so here we will apply the rules that we have studied and we'll try to solve this inequation in one variable. So first one is 3x plus 4 is lesser than 16. So the rule, when a positive term is taken to the other side of the inequation, in this case from LHS to RHS, this plus 4 will go, so it will become minus 4 here. So 3x is lesser than 16 minus 4. That implies 3x is lesser than 12. Okay. Then if we multiply or divide both sides of the inequation by the same positive number, in that case the sign of inequality stays the same. That rule also we have studied. So here in this case, if we divide both sides by plus 4, 3x by 4, sorry, 3, okay, not 4, 3, okay, 3x by 3 and here 12 by 3. So that implies x is lesser than 12 by 3, which is equal to 4. So x is lesser than 4. This is the solution. Now the replacement set, which means the choice from which we have to select the solution set, that is the natural numbers, set of natural numbers. Okay, this. So it is equal to 1, 2, 3, 4, 5, 6 and on and on and on. So the solution set for this first inequation, it is x should be lesser than 4. So it will be this much. Okay, 1, 2, 3. Only 1, 2, 3. This is the solution set for this x lesser than 4. Okay, now the second inequation, 8 minus x is lesser than or equal to 4x minus 2. Okay, again here what we have to do, if we take a positive term from one side to the other, the sign of inequality stays the same and the plus becomes minus. So we'll be using that. Here we'll bring this plus 4x to the LHS side and this plus 8 to the RHS side. So it will become, that implies minus x minus 4x is lesser than equal to, the sign of inequality stays the same, minus 2 minus 8. So this 8 went to the RHS, became minus 8. This 4x went to the LHS and became minus 4x. So that implies minus 5x is lesser than or equal to minus 10. Now there is also another rule in which if the sign on both sides of the inequation, that is LHS and RHS, is changed from their initial sign, the sign of inequality reverses. So here if we change the inequality sign from minus 5x to 5x and minus 10 to 10, the sign of inequality will reverse. It will become greater than equal to. Okay, both sides of the inequation LHS and RHS, we reverse the sign, we change the sign, minus to plus. So it is the same as multiplying minus 1 on both sides. So both sides are multiplied by the same negative number. If you go that way also, the sign of inequality will reverse as per both the rules. So 5x is greater than or equal to 10. Now we'll divide both sides by the same positive number, here by 5 and here also by 5. So when we do that, the sign of inequality stays the same. So here it is equal to x is greater than or equal to 2. This is the solution of the given inequation. Again, from the replacement set of natural numbers, the solution set will be 2, 3, 4, 5, 6 and it goes on and on and on like that. Okay, so it is greater than or equal to 2. So it started from 2 here, from this natural numbers here, in this case it started from 2 and it just went on. So here is another question on linear inequations in one variable. So here it is given, if the replacement set is the set of whole numbers, find the solution set of these two linear inequations in one variable. First one, 5x plus 4 is lesser than or equal to 24. Second one, 4x minus 2 is lesser than 2x plus 10. So let's first see the first bit. 5x plus 4 is lesser than or equal to 24. So here very simple, we'll take this plus 4 to the RHS side, it will become minus. So here it is 5x less than or equal to 24 minus 4. That implies 5x is lesser than or equal to 20. Now we'll divide both sides of the inequation by the same positive number. So it is in this case 5x lesser than or equal to 20. Here 5x by 5, 20 by 5. That implies, I'm writing it here, okay. That implies x is lesser than or equal to 4. So this is the solution of the given set of inequation. Now our replacement set or choice from which we have to pick the solutions, it is the whole numbers, okay, which is starting from 0, 1, 2, 3, 4, 5 like that. It goes on and on and on. So here from this we have to pick the one which satisfies this criteria, x lesser than or equal to 4. So here starting from 0 up to 4, this will be the solution set. So the solution set is 0, 1, 2, 3, 4. Okay, this is the solution set. This is the replacement set. Okay, the first one is done. Next is 4x minus 2 is lesser than 2x plus 10. 4x minus 2 is lesser than 2x plus 10. Okay, so here this plus 2x will take it to the LHS side, will become minus. This minus 2 will take it to the RHS, it will become plus 2. So that implies 4x minus 2x this will not affect the inequality sign, it will stay the same, lesser than 10 plus 2. Okay, that implies 2x is lesser than 12. Here we'll divide both sides by the same positive number, so by 2 by 2. So that implies we have x is lesser than 6. Okay, so x is lesser than 6. This is the solution of the given inequation. Now from the replacement set of whole numbers, lesser than 6, so it goes, we'll just stretch it from here to here. This is the solution set of this given inequation in one variable. So the solution set is zero, 1, 2, 3, 4, 5. Okay, this is the solution set of this inequation. Okay.